Good afternoon. My name is James Hawkins, and welcome to my project for the Center of Undergraduate Research for the spring semester of 2021. I worked in partnership with Dr. Saha in the Department of Math and Computer Science, and we did our project over the blocking of harmful electromagnetic radiation from 5G antennas. Finite size thin metal strips were placed periodically in a dielectric host medium to block electromagnetic radiation of 5G frequencies. In this research, 3D electromagnetic radiation software HFSS was used to model this composite or artificial material. Simulation results showed band stop behavior as expected. In addition to this, the factors affecting the cutoff behavior of the band stop medium were also analyzed theoretically and numerically. In 2002, this is the previous work. In 2002, Smith demonstrated that a metamaterial composed of thin, infinitely long metal rods arranged in a host medium with a periodic fashion exhibits blocking of low frequencies. The explanation is permittivity of the composite material becomes negative at lower frequencies, resulting in unrealistic signal speed, which means no transmission of signals. So essentially, the higher signals would bypass and the lower signals would get stopped. So this was our hypothesis development. Long, thin wires can be modeled as inductance, offering low impedance at lower frequencies. And this is the formula that we use. And so by changing the strip length, L and C can be adjusted to determine a particular frequency to bypass. And so, essentially, we just added the gap. And once we added the gap, we were able to stop and pinpoint what exact frequency that we want to stop. So the simulation setup, the width of the metal strip was 0.1 millimeters, while the thickness was 0.018 millimeters. And the different lengths of the metal strips that we used were 0.7, 0.8, 0.9, and 0.95 millimeters. And so these were the different simulation results that we got. I'll give you guys a minute to view them. Here's the second set. And so here are all of our results together. And as you can see, as the strip length got longer, we got closer to the desired frequency. But our strip length can't surpass 1 because it's all the space that we have. So we're still having to toy around and figure out what we need to do in order to get the frequency that we want to get blocked. And so here's another chart, and you can see the formula that we use to try to figure out what frequency to block. And so what we decided to do was we added little fins to the tip of the metal strips that we used to see if it would make a difference in the level of frequency that it bypasses. And it does. Actually, it bypassed a lower frequency, or it allowed it bypassed a lower frequency. And so it still wasn't what we needed, but that was definitely some great information for us to learn. And so the different factors that we learned were affecting the stop band behavior were the strip was the length of the metal strip, the host material, and then the lattice constant or periodicity, essentially how far spread out each metal strip is. And so here, as you can see on this chart, we're getting closer to the desired frequency. And the transmission coefficient, I could break it down. So essentially, what determines the transmission to pass through is basically whatever number is there. You divide it by 10 and then raise it to the 10th power. So negative 20, you divide it by 10, you get negative 2 and raise it to the 10th power. So 10 to the negative 2 is 1 over 100, which is 1% transmission. And so, another chart, another visual for you guys. And so in conclusion, an artificial material composed of metal strips is modeled in frequency response to simulated. The proposed strip medium shows band stop behavior as expected, but the cutoff frequency is determined by the resonance phenomenon. Proposed band stop material can be used as wearable device in specific applications. Effective periodicity and material property will be investigated in the future. And so I'd like to give thanks to Dr. Saha for working in partnership with me and the Center of Undergraduate Research for allowing me and Dr. Saha the opportunity to pursue this research. And if there are any questions or anything, feel free to send me any emails or anything like that. And yeah, I hope you enjoyed this presentation.